Hi, hello dear, how are you? I'm fine. What about you? I hope you are already fine. So, today I bring a new topic, that is the properties of ligand. In last previous two lectures, I'll teach you. I tell you about the nature of how did not depend upon different factors, the factors that affect did not. And last two previous lecture, second last previous lecture, already stated how the strong ligand and weak ligand affects them. So now today I'm studying the properties of ligand, that how can we differentiate that is the strong ligand or that is the weak ligand. today topic is the Today topic is differentiation of differentiate differentiation of strong and weak ligand. Today topic is the differentiation between strong and weak ligands. So in today lecture, what is the factor that can tell us about that the ligand will be stronger or weaker ligand? How can we classify that the ligand will be strong or weaker? There are few factors. Among them, let's discuss in sequence. The first factor is size and charge. Size and charge of ligands. Size and charge of ligand. What this means, size and charge about ligand? It means that smaller the size, smaller the size of ligands, smaller the size of ligands, smaller the size of ligand, larger will be, high will be. If the ligand are smaller, if the ligand are smaller size, it's have high polarization power, high polarization power, low polarizability, low polarizability. Low polarizability also means low basicity. It means that cannot be shared, that's electron very easily, because its size is smaller. When its size is small, so it cannot be shared. Their lone pair of electrons cannot be easily shared. So low will be basicity, means it cannot be polarized. Basicity, low will be basicity. If larger the size, if larger the size of the ligand, if larger the size of the this phenomena can also explained by uh, Fajan rule. This is these are all the points of Fajan rule. Is it clear? So if larger the size of the ligand, low will be polarization power. Low will be polarization power. High will be polarizability. It means that it can be polarized fastly, easily. It can be polarized. High will be basicity, means it can be easily donate electron, because it can polarize easily. High basicity. If high the basicity, it means according to this concept. If so let's take some example about uh, so let's take some example about that, like the sequence in which fluorine ligands, chlorine, iodine, astatine, fluorine, chlorine, bromine, iodine. In this ligand, we already know that the iodine has the size of these ligand as size size order, increasing size, decreasing size order, or increasing size order. Chlorine has a smaller size than chlorine. Chlorine has smaller size than bromine, while bromine has smaller size than iodine. So here the size increasing in this direction from left to right or from top to bottom in periodic table. When the size increases, its polarizability will increase. Iodine has high polarizability, means it can be easily shared electron. So we can say that larger the size of the ligand, the stronger will be ligand. Stronger will be ligands. Ligands. Smaller the size of the ligands, the weaker will be the ligand. If you compare these atoms, if you compare these anions, if you compare these anions, they will if you compare these anions, in among them iodine is very strong ligand as compared to fluorine, very strong ligand as compared to fluorine, while fluorine is very weak ligand as compared to iodine. So the also it is the order of ligands. Strength of ligand increases from left to right or from top to bottom in periodic table. Also, also in one other example, like in H3, H2O, HF. Here in HF here is 3 lone pair, here in oxygen here is 2 lone pair, in water here in nitrogen is 1 lone pair. So the size of central atom is like nitrogen, oxygen, fluorine, it is decreases from left to right, from left to right, it is increase in periodic table. So if the size decrease, sorry, it is decreases from left to right because electronegativity increases from nitrogen towards the fluorine. So that's why the size increases. So the smaller the size, smaller will be its ligand strength, means it will be this weak ligand, while Na3 will be strong ligand as compared to water. Na3 is strong ligand, while water is weak ligand, while HF is very weak ligand as compared to the both one. So these are the concepts of size and charge of ligand. We can compare, we can find the strength of any ligand when we know the size and charge of the ligands. What is mean by charge of ligand? So here some other example, like here is O minus and one is O minus 2. Which one will be stronger ligand? Both have lone pair of electron, free lone pair of electron. Which one will be stronger ligand? O minus 2 will be stronger ligand because high the charge will be high. It can be easily polarized, it can easily donate electrons. So it will be high the charge and electron, high the charge and atom, high will be its ligand strength, means it will be stronger ligand as compared to O minus. So it is the topic. You can also take screenshots. If any problem you can ask in comment section. Okay, thank you. Now I am going to clear the board. uh, I am going to clear the board, so you can take screenshot or you can rewind the video. Okay, thank you. So let's come to second point, basic character of ligand. What do you mean by basic character of ligand? It means that it can also, we can also predict the strength of ligand from the basic, if we know the basic character of the ligand. It means that strength of ligands strength of ligand is directly proportional to the basic character of ligand. Basic characters of ligands. What this mean? It mean that stronger the basicity power, the basicity power, stronger the basicity power will have stronger the basicity power of the ligands, stronger will be stronger will be the ligands. If weaker the basicity power, weaken the power basicity power of the ligands, weaker will be base, it is so simple. So let's take some example on this topic. like NH3, NH3, H2O, H2O, HF. Here is some example. I already explained this point on the previous points in size and charge of ligands, but you can also take this example in this point also. Here you know that nitrogen has the greater basicity, Na3 has greater is more basic than H2O, which is more basic than HF. Means HF is very weak base. Because HF is high electronegative element, so it hold the hydrogen atom, it hold the lone pair, it hold the lone pair very tightly, while the while the oxygen is not as much electronegative like fluorine, so it can they cannot hold their lone pair tightly like fluorine, but Na3 is too much less electronegative. So, or you can also take the example like that. You can also explain the concept of this point is like that the hydrogen has one lone pair while oxygen has two lone pair while fluorine has three lone pair. The fluorine lone pair, if the central metal atom have a pi lone pair, if the central metal atom have some electrons in a d orbital, if the central metal atom has some electron in d orbital, so fluorine cannot effectively approach to this central metal atom, or like oxygen will be uh, show some approach to the central metal atom as compared to fluorine, because fluorine has large the number of lone pair, so it will show the resistance, it will show steric effect to the lone pair of the central metal atom. But nitrogen has only one lone pair, so it can donate easily to this system, so the necessity of the nitrogen is very greater as compared to water, which is compared to Asia. So Na3 Na3 can Na3 is a stronger basic, Na3 is stronger ligand, while A2 is weaker ligand as compared to Na3, but H is very weaker ligand as compared to both of them. So this is the concept of basic strength of basic character of ligands. So you can also take the screenshot of this lecture. uh, Now I am cleaning the boards, or you can rewind the video. Okay, thank you. So let's come to the third point. The third point is the pi bonding capacity. Pi bonding capacity means pi bonding capacity means the pi bonding capacity of ligand. It means that some ligands have pi characters. Some ligands have some ligands are called pi acid ligand. Pi acid ligands. Pi acid ligand. What is meant by pi acid ligand? Pi acid ligand are those ligand mean that can share electron. Pi acid ligand are those ligand that can share electron. That can share electron. Share electrons. Share electrons, as well as it can accept lone pair of electron. Lone pair of electron. Like it means the pi is a ligand that have one that has one pi empty orbital, pi vacant orbital, pi vacant orbital. For example, CO carbonyl, CO, Cn negative, PR, ASR, ASR. These all are the example of pi acid ligand. So if the ligand have character that they are the pi acid ligands, that makes these ligand will be called a stronger ligand. These ligand will these ligand will make a strong bond, strong interaction with the this ligand will have strong interaction with the central metal atom. Stronger will be the ligand. Is it clear? Okay, so for example, here is this is carbonyl carbon, here is one oxygen, that is one lone pair, that is one orbital, this is one orbital. This is this carbon is in this orbital, it has two electron, so it is lone pair, but this orbital is vacant. So this carbonyl carbon, it can share n plus, it can share these electron to the centromere atom, but if the centromere atom have also the lone pair, it has also electron in d orbital, so it can accept through this centromere to this orbital. So that is called pi acid ligand, mean it can share electron as well as it can accept electron. So it is the pi acid concept. So is it clear? It means that pi acid ligand will be called stronger ligand. These all ligand are will be stronger ligand. Okay, let's take screenshot from this point. I'm going to remove to clean the board. Okay, thank you. Or you can also rewind the video. Thank you. So the second point, let's come to the fourth point. Fourth point of today's topic, it is the last point of it is the last point through we can differentiate the stronger ligand and weaker ligand. What is meant by steric effect or steric handles? Some ligands show some ligands and some ligands here and some ligands there is also there is also. There is bulky group in some ligand, there is bulky group, bulky bulky groups. This bulky groups, this bulky group doesn't allow doesn't allow the ligands to make interaction with central metal atom because of because the ligands because the bulky group show steric hindrance to the system, to the coming group, or to the coming group, or CMA central metal atom. Is it clear? So let's take some example. Here is NH3, is NH2CH3, or you can say H2NCH3, also HCH3NCH3, HCH3NCH3CH3. In each case a nitrogen has one lone pair of electron. So but with increasing from left to right, in this case from ammonia to primary amine, secondary amine, tertiary amine, the bulkiness increases from left to right in this clipboard. The tertiary amine 3-degree amine also show greater steric effect, greater steric hindrance to the coming group, or to the central atom, while it show less steric hindrance. The secondary amine show less steric hindrance, while primary amine show very less hindrance. But ammonia cannot show any steric hindrance to the system, cannot show any steric hindrance to the system. So ammonia can act as a good base, so it can also act as a stronger ligand as compared to the primary amine, which is less than, as compared to which is greater than the secondary amine, which is greater than to the tertiary amine. The strength of a ligand will be like that. Na3 is greater than, Na3 is stronger ligand than A2CN3. Then Na3 is stronger ligand than primary amine. Primary amine is stronger ligand than secondary amine, while secondary amine is stronger ligand than tertiary amine. Mean tertiary amine is very weak ligand, while ammonia is very strong ligand. So this is the last point. I hope you will be cleared. Your all confusion will be clear about what is strong ligand and what is weak ligand. So these all are about the lecture number 6, lecture number 6 of crystal field theory. So is it right? Any confusion? If you have any problem, any confusion, you can ask me in comment section. Okay, or you can also ask me in my whatsapp, or you can also take any class that you want. If you have any confusion in any topics, then I can arrange the class. You can talk me, I will be arrange the class for you special. It will be special class. Oh, so you can be clear there. Thank you. Okay, bye. Be reading. Take care. Goodbye. Best of luck. Thank you.